Hey, this is Kyle Grossmiller. I'm a technical product specialist at Everpure. And in this technical demo video, we're going to go over how to set up Azure Local with Hyperconverged storage with the Everpure FlashArray. Step one is to configure your Azure Local nodes. This means that you have a deployed Azure Local instance, which is what we're seeing here. Basically, you go through all the steps and prerequisites and then deploy it from the Azure portal. We can see that in this just quick start example, we've got two healthy Hyper-V nodes up and running. And what I'm going to do here is go ahead and remotely PowerShell into one of them. The steps that I'm about to show you for preparing these nodes, you need to run on each node within your cluster because we're doing kind of per node things. The first thing I'm grabbing is this Mellanox driver. We support Fiber Channel at launch, and so what I want to do here is make sure that I've installed the latest and greatest Mellanox adapter driver firmware for these Fiber Channel cards. When I enter this Windows driver command, we can see that I'm at a release that came out earlier in 2026. So this basically confirms that these Mellanox cards are at the version that I want. This is very important. Azure Local will not work without that. Next on this node, I'm going to install the Windows feature Multipath IO, aka MPIO. This does take a few minutes, and a couple reboots are kind of required throughout this process to get these Azure Local nodes configured. There we can see it's installed. Now I'm adding MSDSM support for the Everpure FlashArray, removing other stuff, so I'm not using any other products here. It's worth mentioning too that in the soon to come out disaggregated setup video, we'll talk about how to set this up with that. So there's potentially some extra steps here. I had to reboot the host there because I couldn't set up round robin multipathing because MPIO needs a reboot in order to be online. So now that this host is back up, I'm going to log back into it. And what we can do here is confirm that the Everpure FlashArray is indeed on the list of vendors and products. This means that MPIO will claim that device as it should. These are the default MPIO settings. I'll put in the command here. This is all on our Microsoft platform guide on our support site. So there's a lot more detail in terms of these settings, multipathing strategies. I'm using round robin here because we have less than 10 paths. If you have more than 10 paths, you probably want to look into using LQD or least queue depth. So I set my load balancing policy as round robin here because I only have, I think, 4 paths. Now I'm setting some MPIO timeout values. These have been kind of lab tested in our environment. If you have finicky or other latency sensitive applications, your numbers may vary here. But as you can see, that's what we recommend. In our quick start guide KB article, which I'll link to in the description, we have a lot more detail about this kind of stuff. I'm just going through it quickly here to get you through this demo as quickly as possible. Last step is to grab the WWNs from each host and record them. In part 2 is where we actually set up the Everpure FlashArray. We do have a Pure Storage PowerShell SDK. If you haven't noticed, this entire demo video is being done in PowerShell because it's easily scriptable. And you know, you can, and honestly, this is the easiest way to get all this stuff set up. So I install and import the module. Here I'm just establishing a connection variable to the FlashArray management endpoint, putting in my username and a credential. And now using that $CONN connection, I'm going to go ahead and create my host objects. These are different host objects than the previous example I showed, because I'm using a couple different clusters here, so apologies for that. Here I'm creating the actual host object name. You can also optionally pass the WWN here, which is what I'm showing here. So those WWNs that I recorded on each Azure Local node from the previous section is what I'm passing in here. And here I'm doing it for my second host in this cluster, giving it the WWNs. Clearing this. Next, the other thing we can show is now I'm creating a host group. Host group is just a container that contains those two hosts, so I can connect volumes to them. As we can see, this is just showing it in the GUI. You know, I created the host objects, added the host ports, and added them to a host group. So really our last step is to provision a volume. In this case, it's a 10 terabyte volume. I'll use a 9 terabyte volume later, just because, again, I'm using multiple clusters here for part of this setup because they were in different states. And really all I'm doing here is adding that volume I just created to the host group that I created earlier within the section. Here again, we can see it in the GUI. There's my host group with the connected volume with the two hosts. And so with that, we are basically done from an Everpure FlashArray standpoint. All this stuff can be done in the GUI, but since the theme of this demo is PowerShell, I did that. The last step is to take that volume that we've just provisioned and configure it as a clustered shared volume. So I'm just rescanning first. Now I can do this get disk. The number for this one is a 9 terabyte volume that I provisioned on a separate cluster. We can see it's offline and it's raw partition style. One other important check is just to make sure that Microsoft DSM is properly claiming this. Again, that's that MPIO setup that we did in the first part. So this is just confirming that all works. What I'm going to do now is bring this disk online. It's number 3. It's not number 5. So that's all that does. Again, this could all be done from within the Windows operating system as well from the GUI, but we're just showing it here just to make it PowerShell forward. Next thing here, I am initializing my disk. Oops, that's the wrong number. It's number 3. My bad. Initializing my disk with the partition style GPT that is required here. And if we see that it switched from partition style raw to GPT. And now we need to create our initial partition on disk number 3. So that's what we're setting up here. And here we can again see everything's online, and we're just kind of slowly building up this effectively Hyper-V disk to use with Azure Local. This is important. We are using the NTFS file system that is required for clustered shared volumes with external storage. And then our allocation size is 64 kilobytes. Those are both, NTFS was required, allocation size 64 kilobytes is important, and we recommend it as well. And then I actually gave it that label as well that you can see there. Now that the disk is effectively formatted, partitioned, and online, I'm going to add it as a clustered disk. I should mention you only have to do this procedure I'm showing in this section on a single Azure Local node. All the other local nodes will become aware of it as you online the clustered shared volume, which is what I'm doing right here. So basically I'm adding it as an available storage option first, and then you add a clustered shared volume. And now the clustered disk is in fact online and available to all nodes in the Azure Local cluster. And in this case, it is backed by a FlashArray. Oops, it's not all. Sorry about that. It is, I think it's no all. Yeah, so there we can see it. There's a couple others here too. Because this is hyperconverged, you're going to see other disks. Other people work on this as well. See that local volume directory. So the CSV is mapped as a local drive on each of your Hyper-V hosts. That volume is important. You can find it in Windows Admin Center as well. So there are a few different places you can pull that volume. The reason why you need that volume is that now I'm jumping back to the Azure portal and I'm going to create a storage path. So this is how you actually map your local FlashArray, your Azure Local FlashArray backed volume as a CSV inside of the Azure portal. So that's why I'm grabbing that kind of C:* file system path. You can rename volume 1 if you want to as well locally. I just didn't do that here. But I am going to give it a unique name in the Azure portal just so I can tell what it is relative to other things. So I'm creating the storage path now. It does take a couple minutes for it to come up. And then once it does, this is kind of one of the really cool and powerful things about the Azure portal is, I've got this Azure-like experience, but I can use that on my local devices in my local data center, right? So those two hosts that we saw are actually running in an Everpure data center. I'm going to add a VM image from the Azure Marketplace. So I'll go ahead and just save it as, we'll just call it Quick Start. Since this is a Quick Start guide, Quick Start Windows 2025. I'm going to pull an image. There's a whole long list here of images you can pull. I'll just grab, I'll grab this one, or sorry, I'll grab this other guy. And then here under storage path, I'm going to choose that storage path that I just added so that the image actually downloads to that local device, and then I can deploy images from it. That will kind of be a subsequent video. But as we can see, if we go back to VM images under Azure Local, we can see that we are indeed downloading that image, and it will become available to deploy VMs off of once it finishes that download. Thank you for watching. Again, this is just the first part. That's how you set up Everpure with Azure Local, and we'll see you next time. And here's the guide to see more stuff. Thanks again.